All right, let's work on the fill in the blank problems. So in this problem, we're supposed to find the last three digits of 2015 to the power of 2015. So the last three digits is exactly what mod 1000 does. So we need to figure this out in mod 1000. So first up, what we want to do is reduce the base, 2015, in mod 1000. So that reduces to 15, right? We can take away two 1000s and we have 15. So we'll search for a nice pattern with powers of 15. So 15 to the power of 0 is 1. 15 to the power of 1 is 15. 15 to the power of 2. Well, it's kind of a big number. Let's use a calculator here. So 15 squared is 225, and we want to divide by 1000. So there's no real reducing that. It's still 225. So nothing we could do about that. Let's see what happens when we multiply that number by 15. So multiply by 15, it's 3375. So 15 to the power of 3 is 375 as the last three digits, mod 1000. Let's multiply by 15 again. Multiply by 15, we get 625 as the last three digits, so 625 is the next one. 15 to the power of 5, let's see what that one gives us. So it would be 625 times 15. And notice it takes us back to 375. So we've successfully found a pattern. So 15 to the power of 5 is also 375, and that means that 15 to the power of 6 is also 625. So as we go along, we want the 215th or 2015th power. So let's notice that our pattern is of size 2. Right? There's two things in our pattern. So the power in mod 2 is of interest, and that will give us the answer to this problem if we convert it correctly. So if the power is 1 in mod 2, so those are the odd numbers, like the power of 3 and the power of 5. So if the power is 1, our answer is 375. And if our power is 0, those are the even numbers, so 15 to the power 4, 15 to the power 6, and so on, the answer is 625. So in our case, our power is odd, so the answer is 375. In the next problem, we're supposed to find the smallest positive integer, which is both a multiple of 6 and 11. So we'll need to use the mod magic trick for 6 and 11. The trick for 6 is exactly the trick for 2 and 3. So use the trick for 2, 3, and 11. Okay, so the trick for 2 tells us that the last digit has to be an even digit. Now we're only supposed to use 1 and 6, and we're supposed to use a 1 and a 6 at least once. So the very last digit of our number has to be a 6. It can't be a 1 because then it's not divisible by 2 anymore. Let's think about the trick for 3. We need to have our number have its digits add up to a multiple of 3. And we know that we have to include one more 1 because it says we need at least one 1 and at least a 6. But as soon as we include one more 1, we actually need to include 3 of them because that's the only way that we're going to add up all of the digits here to a multiple of 3. In this case, that multiple is 9. Now this works for 2, it works for 3, but unfortunately it does not work for 11. So our trick for 11, we'd take 6 and we'd minus 1 for 5, and then the 1 minus 1 would cancel out. So this would have a remainder of 5 in mod 11, and that just won't work for us. We need a remainder of 0 in mod 11. So the question is, how can we make the smallest such number? Now, 4 digits is the absolute minimum. We can't move the 6, and we can't actually move the 1s anywhere because the 6 has to be pushed to the far right. And if we have 1 1, we have to have 3 1s. So our number has more than 4 digits. So 11 does not work with this number. Therefore, we have more than 4 digits. Okay, so let's work on the possibility of having 5 digits. So once again, if we have 5 digits and we have to include a 6 at the very beginning of our number, or the furthest number to the right, we have to include 3 1s. Now the next number, it actually can't be a 1, else we spoil the condition for divisibility by 3. If we put in a 6, that's okay. We can have our 5 digits. Let's put in the 6, pushed furthest to the right, so that we make it as small as possible. Right? The bigger numbers pushed to the right-hand side make the whole number as small as possible. So this number could work in terms of divisibility by 2 because it ends in a 6. It could work for divisibility by 3 because the digits add up to a multiple of 3. In this case, 6 plus 6 is 12, plus 1 plus 1 plus 1 is 15, a multiple of 3. But it still doesn't work with 11. So adding up the digits alternating the sign just doesn't work. The 6 minus 6, that cancels out. The 1 minus 1 cancels out, and you're left with 1. Now the very next smallest digit placement that we can make here is to move the 6 over 1. And this ends up working out perfectly. So this number is divisible by 2, it's divisible by 3, and it's also divisible by 11. So 1, 1, 6, 1, 6 works.